Hello, this is question 4 from the 2023 step 2 paper. We've got to show that if that equals 3, then that equals 0, and then deduce some stuff off the back of it. Right, so we've got a self-contained bit of algebra at the beginning. So we've got some quadratic equal to 3, and then a quartic equal to 0. So there's going to be lots of squaring involved here. As I might as well expand out that bracket. X squared minus 2 root 2x plus 2 is 3. And then I'm going to want to square all this again. So I'm probably best splitting terms across sides, because then I'm going to have fewer things to square. So x to the 4 is going to be equal to 8x squared plus 4 root 2x plus 1. And what am I trying to get? I want to get rid of those square roots and x terms. So I want to get rid of that 4 root 2x. Well, I know that 2 root 2x is x squared minus 1. So I've got 8x squared plus 2 lots of x squared minus 1 plus 1. So that should be it, hopefully. So x to the 4, let's get everything to the left. So I've got 10x squared, so minus 10x squared. Minus 2 plus 1 is minus 1 plus 1, 0. Okay, so that's come out. Now we need to deduce that if f of x is that thing, then f of root 2 plus root 3 is 0. Right, okay, so we don't have to put it into the quartic, we can put it into the quadratic. So if, what am I trying to say? Yeah, if f of root 2 plus root 3 equals 0, then that means that we're going to have root 2 plus root 3 minus root 2 squared equals 3, which it does. So there we go. So that's done part 1. Part 2, find a polynomial g of degree 8 with integer coefficients. Right, so again, we're sticking with these integer coefficients, such that g of root 2 plus root 3 plus root 5 is equal to 0. Write your answer in a form without brackets. Right, two things are jumping to mind now on this. Now they specifically said here that we were looking for integer coefficients. There's certainly a different way I could have done this. As in, if I wanted to get rid of the 2 root 2's in here, I could have gone for x squared minus 2 root 2x minus 1. So kept it all together on the left-hand side rather than splitting them across both sides, and then do it like a conjugation. So just change the sign on the square root bit. And then if I do that, it's then going to cancel out as we're going through the terms, isn't it? Except for when it's multiplied by itself. So I'd get an x to the 4, and then I'd have the plus 1. I'd have a, so when I do the x cubed terms will cancel, and the x to the 1 terms will cancel. And then I'm going to be left with a minus x squared, another minus x squared, and then the minus 8x squared. So yeah, that comes out the same way. So this is probably a better way of avoiding irrational coefficients. So if I want integer coefficients, that might be a way to go about things. So that's one thing that springs to mind seeing this. I mean, their intention wasn't entirely clear in this part. I mean, were they just trying to avoid odd powers of x, or were they trying to get rid of those irrational numbers? Anyway, so that's one thing. The other thing that's bothering me though is this, because we've changed now. Here we wanted a root that was root 2 plus root 3, and they've used this thing here with a minus root 2. We've now got root 2 plus root 3 plus root 5 as the root we want to get. So does that mean I still want to do x minus root 2 squared equals something that I want to work out for that particular root? As in, for this root in the first part of the question, when I put it in here, I get a 3. So I need to do the same thing with this root to get a number here. So that's one option. Or do I want to do an x minus root 2 minus root 3 squared equals 5? Yeah, don't really know at the moment which one of those I want to do and whether it's going to matter. I mean, but I want to work up to a polynomial degree 8. So that means I'd be squaring this and then squaring it again, and that looks a lot worse, having a root 2, root 3 in it, because I'm going to have that bracket everywhere. I'm going to have to square that. It's going to be in the x terms, it's going to be in the constant terms. That feels like it's going to be worse than doing this. Let's see what I get if I get the, well, whatever this is going to be, the right hand side. So that would be root 3 plus root 5 all squared, which is going to be equal to 8 plus 2 root 15. See, that looks a lot better, doesn't it? If I was doing x minus root 2, well, if I square that out, I'm going to have an x squared. This is just sort of a bit of side work in here if I actually get onto the actual answer. X squared minus 2 root 2x plus 2. Then I'm going to be taking off an 8 and taking off a 2 root 15. So if I've got that, I've got one square root in that term and one square root in that expression at the end for the constant. So that seems simpler, doesn't it, for squaring it up, particularly if I'm taking this approach. So I'm going to go with that, I think, rather than doing this, because I think that's going to end up being a mess. But now I'm going to have to go to another sheet. So 8 plus 2 root 15 is what I'm looking at here. 8 plus 2 root 15. So I'm saying x minus root 2 all squared equals that. So that's my x squared minus 2 root 2x, and then I'm going to have a plus 2, so a minus 6 minus 2 root 15 equals 0. So that's what I've got, and now I'm going to want to multiply that by x squared plus 2 root 2x. Can keep that as a minus 6, and then a plus 2 root 2 15. Not 2 root 2, a 2 root 15. So I want to multiply those together. Now a lot of these terms are just going to disappear, aren't they, with all these pluses and minuses. So I've got an x to the 4. Then I won't get any x cubes because they're just going to cancel. So I'll have a minus 6x squared and another minus 6x squared. So minus 12x squared. I won't have to multiply the x squareds by the 2 root 15s because they're going to cancel. Then I'm going to go on to these 2 root 2x's. So I'm going to get a minus 8x squared. Then I don't need to multiply them by the minus 6's. I do need to multiply them by the 2 root 15. So that's going to be minus 4 root 30 times 2. So minus 8 root 30x. And then the 6's will give me a plus 36. And the 2 root 15s will give me a minus 60. 4 times 15. Okay, so that's that. So that is x to the 4 minus 20x squared minus 8 root 30x minus 24. Okay, and we want to get up to degree 8. We've only got one square root left, so hopefully if we do the same thing again, so multiply by all of that, so with a plus there, then it'd be nice to think that we won't have any square roots left. So I'll have x to the 8, then I'm going to have a minus 40 x to the 6, and then I don't need to multiply by the, I won't have any x to the 5s. I'm going to have minus 48 x to the 4. Then I'll have plus 400 x to the 4. Don't need to multiply for the x cubed terms. So I'm going to have 20 times 24 is 480. I'm going to have 2 lots of those. So 960 x squared. Okay, where am I up to? So I'm now doing the 8 root 30. So that's going to be minus, so I've got 64 times 30. So 192 with a 0 on the end. And then I'm going to have plus 24 squared, which is 576. Right, I've got no square roots. This is looking good. So That leaves me with what? X to the 8 minus, that's the only x to the 6, so 40x to the 6. X to the 4s, I've got 352 of them, which is a lot. And then I've got, 1920 is double 960, so I've got minus 960x squared, and then plus 576 equals 0. Find a polynomial of degree 8 with integer coefficients such as that equals 0. Yeah. Okay, right, that was a slog, but yeah, I mean, it was just algebra. Right, part 3 then. So let A, B, and C be the 3 roots of that. Find a polynomial h of degree 6 with integer coefficients such that those are the roots. Write your answer in a form without brackets. Right, I think I'm going to need another sheet again. Right, so they've given us a cubic which has got roots a, b, and c. We now want polynomial degree 6 that's got roots at a plus root 2, b plus root 2, c plus root 2. So they've moved all of the roots off to the right by root 2. So roots have moved to the right by root 2. So that then means we can translate the cubic, get the same roots, but that's going to have, well, it's not going to have integer coefficients, which is why we want to go through the same process that we've just been through in part 2 in order to get rid of those square roots. Okay, so that seems okay. So we can say that we've got t minus root 2, because we want to move it off to the right, cubed, minus 3t minus root 2 plus 1 is equal to 0. So I'm going to have to expand it out. Nice. I'm going to have t cubed. Then I'm going to have a minus 3 root 2 t squared. Then it will be plus 6t. And then minus 2 root 2. Minus 3t plus 3 root 2 plus 1 is 0. So that's t cubed minus 3 root 2 t squared plus 3t plus root 2 plus 1 is 0. So I want to multiply that by t cubed plus 3 root 2 t squared plus 3t minus root 2 plus 1. Right, so another messy looking thing to deal with, but still. So I'm going to get t to the 6, then I don't have to worry about t to the 5s, but then I'm going to have 6t to the 4s, 6t to the 4. Then I don't have to worry about the root 2s, then I'm going to have 2t cubes, 2t cubes. So move on to this 3 root 2 term, so I'm going to have minus, so it's going to be 9 times 2, so 18t, not squared, t to the 4, 18t to the 4. Then don't have to worry about the t cubed, but I do have to do that root 2, so that's going to be a 3 times 2 times 2, so, and it's a plus, isn't it? So plus 12t squared. Then I don't have to do the last term. Then I get a 9t squared plus another 6t minus 2 plus 1. Wow. So that's t to the 6. How many t to the 4? So I've got minus 12 t to the 4. T cubes, I've just got 2. Then t squareds, I've got 21. Then t's, I've got 6. And then I've got a minus 1. Okay, so that's the polynomial with those roots. Yeah, that seems fine. On to part 4 then, the last part. This has been a slog of algebra though, isn't it, all the way through. Find a polynomial k with integer coefficients such that that equals 0. Okay. Right, well, this looks very similar to the first part of the question, doesn't it? I mean, we've got the same thing, but we got cube roots rather than square roots. But otherwise, we've got the same as this here. So, am I doing that again? I don't really know. I mean, maybe it is. I mean, if I had a x minus the cube root of 2 cubed equals 3. So say that was my starting point. And then, so I'll cube that out, x cubed minus 3, the cube root of 2x squared. Then it will be plus 3. I'm going to keep them as cube roots of 2. Just write it out twice. And then I'll have a minus 2 equals 3. And that looks really ugly. That looks really ugly. And I don't know how this fits with... I've been doing conjugates all the way through, although in the first part I didn't do conjugates. So maybe I can go back to my original method of getting rid of these cube roots. I don't know. Anyway, so what have I got here? I've got an x cubed. Well, I've got some nice terms and some ugly terms. So I'll do what I did right at the back at the beginning before I noticed they were going for integer coefficients. I split the terms left and right to make them easier to square, in this case easier to cube probably. So I've got x cubed minus 5, so they're the terms that don't have any cube roots in, and then that will be 3 cube root of 2 times x, and then x minus, what is that, the cube root of 2. Okay. Oh, well, I know what x minus the cube root of 2 is. So, yeah, this is working out exactly the same as the first way that I did the part 1, because that is now the cube root of 3, because that's the statement we got at the beginning. Right, so now I've just got one term. I've got friendly terms on the left-hand side and one term on the right-hand side. So I've got x cubed minus 5, which I can cube all of that, is going to be equal to 27 times 6x cubed. Okay, so that's what, 135 plus 27, so 162. So I need to expand out this side. So I've now got x to the 9, and then I'm going to have minus 15 x to the 6. Then I'm going to have plus 75 x to the 3, and then I'm going to have minus 125, and then I need to take off 162 x cubed. So well, I've got all that together. So I've got x to the 9 minus 15 x to the 6, and then what's that, 87 x cubed minus 125. Right, so my original method doesn't look as bad as, well, it never really looked bad, but at least it's become useful again. Sort of done full circle on here of coming back to what I originally did with part 1 in order to, split these terms around. So that was a slog of a question, I would say. There wasn't really anything that interesting about it. It was just a lot of very, very heavy algebra, which could easily lead to mistakes. I mean, I wouldn't guarantee 100% I've ended up with the right coefficients here, because it's just so easy on every part of the question. I mean, part 1 was fine, but part 2, part 3 and part 4, it'd be so easy to lose a number somewhere on a coefficient. So yeah, it was fine though, but not the sort of question. I don't think I would have picked this one as being one of my 6 if I was doing the test.